industry that is good to have in your CV, like some knowledge on AutoSAR.
So is there any other software also apart from AutoSAR where you people use for EV? Apart from MATLAB, I understood like MATLAB you'll be using. Do you use HIL's also hardware and loop system for testing their Opal RT
Yeah,
or IM?
yeah, you use the hardware loop, software loop, like there are these these platforms that you use for testing the vehicles,
Yeah, so
like in
that's
the
why our
companies.
students also those are doing project in that they're easily getting a job. But is there any other software where students can be taught apart from MATLAB and AutoSAR also? Since you said it's an open source, we'll try to explore it. Apart from that, is there any other software where you have seen in industry for automotive industry they require?
Yeah, but like there are several other softwares, but maybe they are more specific, or like for finite elements simulation, like for motors. Like we need for the magnets of the motors, we need different softwares. Temperatures usually go for different softwares as well. So it depends on the specific areas have different softwares, like
Okay. So I
electronics.
could understand. So if finite element analysis you want to go, you go for ANSYS or many other softwares like that. For temperature, you have to go for specific softwares. So each companies might be they are using different softwares. So like I
Yeah,
think specifically
exactly.
for mechanical design, we have to go for softwares or profiling. We have
Yeah,
like
for
for
instance.
tomorrow and day after tomorrow, this finite element analysis only we are going to do ANSYS with ANSYS. So might be that will also be useful. It's really interesting to know that industry is also like more into these softwares. So like knowing these softwares are very much important. Yeah.
Yeah, for instance, like if you want to go deep to electrical side, then you use PSpice. Like it depends, and you use this in the industry as well. Like
Okay. Peace Spice also you people use.
yeah, we use when it's required more deep research in certain fields, that we go for more specific software. But on the high level, top level, we use MATLAB and Simulink. And sometimes MATLAB is not the higher level. We use different systems, like to give an overview of entire vehicle. We use more yeah, top level softwares, like for system modeling.
Okay.
So some, yeah, MATLAB is more for engineers that work with specific fields, like drivetrain, battery management, electrical field. But the vehicle is there are several other fields. So sometimes people they just don't know about MATLAB. They work with CATIA, that is more mechanical software, or Electra. Yeah, there are several softwares that to use for developing a car.
Okay. Yeah. Any other participants, if you have any doubts or anything, because he has worked with the battery management system on the hardware also. So if somebody wants to ask, you can. Mostly we you work with lithium ion batteries only, na? The combination for regeneration, for going
Mm.
up the hill, the super hard, like now many people with super capacitors and ultra capacitors, also many researches are going on. So is it there in market? Like, do you have cars where these super capacitors are also used?
Not that I know. I don't know. I know some trends that to have swap batteries, but like we charge the batteries, we swap in some stop stations, and then we
So that is
continue
an
the.
only in research side, I think. Now also it is on research,
Yeah,
not much in because since you have worked with Scania, Volvo, with electric thing, so since it is in might be not in market as such, only in
yeah,
research
exactly.
stage.
Yeah, about batteries, I can highlight like there is a Fraunhofer Institute in Germany. They have lots of research in this field, and they have a full open source platform for battery management system. It's called Fox BMS.
Fox
If
BMS.
if you have interest, you can have a look on that, and then it's very complete system, and you can learn a lot. Yeah.
So what are the other open source? You said one is Fox BMS. You said any other battery management system, open source software?
Yeah, now I don't remember. Maybe I can
Don't
think
remember
about
it,
in
yeah.
something, but yeah.
Because these open source softwares only we are also looking for, so that it will be easy. We can teach our students so that getting
Mm,
job will be. So the thanks. This also like Fox BMS and this Autos are two new open source softwares which I could hear from you. And Tatiana, in case if you come across any other open source softwares, you can please share the link or like the name so that we can try to teach our students also about these open source softwares. It will be a better thing. And
yeah.
participants, if you don't have any other question, I will just wind off the session. Do you have any other questions?
Sir, if we are planning to develop the charging station, so what things we have to keep in mind, sir? Any idea? Because we are planning to do it. My students are working on this thing. So please.
Yeah, there are lots of charging stations. There are very strict standards about the charging sequence. Like it's not easy to handshake with the vehicle. Like there are charging sequencing process that you should follow, and the standards they define this. So there are safety requirements and charging sequencing requirements. So this becomes a bit complex in these terms. So you should have a very good handshake with the vehicle, like before start charging. So this is my advice. Like first, try to find out what are the requirements about these things, charging requirements and safety requirements.
Okay, we have to first look for the like what type of charger we want, what type of vehicle we want to charge. Based on that, the ratings and other than standards, all standards we have to. Because in Sweden, when we were working, also I could see that before starting the project, we first look into what are the standards. Because in
Hmm.
India we don't have such system. We make the system and then look for standards whether it is meeting or not.
Yeah.
But I could find there first we take the standards, look into it. What are the different standards? Self test methods are given, like your device under test should satisfy this. So I
Yeah,
could.
about charging stations, I can say okay, connecting the power source supply to the batteries is the easiest part. Like okay, connect the power supply to the batteries and you start charging. This is the easiest part because it's we understand it's simple. It's just current flow from one side to another. But what is really complex is the rest of the things about is about communication, is about handshaking with the vehicle, their current rating, like isolation. Lots of we are working with high voltage, so there are lots of requirements about safety with the isolation, earth to ground issues. So these machines they become expensive and complex because the other things, not because they're connecting to power source.
I also agree with Tatiana that first, ma'am, you were asking first try to study the standards. What is if you take a charger, there are lot of standards already defined. We have to take that, and in that they have given test methods. So you have to first of all put your machine, whichever portion you're taking, put under test, and you have to see that it is meeting those standards step by step. Then, as he said, the communication protocols and other things, all these things have particular standards. So first we have to, and all these standards are not free. You have to pay and get it. So
Mm.
like one of the standard of power quality I've shared with you people, which I told you not to share forward also because those are all paid ones. Okay. So
Mm.
like so that is one thing. What he is also telling that you have to look into the standards first, and then you have to go about. And do you have any other doubts, or can we just wind it off? Because I think it's morning and he has to go for his office also.
Yeah, here is quite early.
Yeah,
I
yeah, it's
guess
quite
five
early, but
hours
anyway, you
earlier.
have to start. So somebody was asking for the open source software. So one is for battery management, the Fox BMS, and Auto. I'm just putting it in the chat. You can just take this. And apart from that, if I will be in touch with him, like in case if he comes across any open source softwares, he'll share, and I can share it with your with this
Mm.
group. So one question is there in the chat, Tatiana, how to improve the efficiency of the battery, how to minimize the basic losses in battery, lithium ion management, lithium ion magnesium battery to increase the range of vehicle in kilometer.
Yeah, this has to do with the developments on the cathode for the batteries, lithium-ion batteries. So we need a better chemistry to prevent losses in the when you charge and discharge the vehicle, because it's the part that heats more in the batteries. So research they should go in that direction, like how to optimize the cathode of the lithium-ion batteries. And besides this, is more about the system level, like how to manage the charging, discharging at system level. Uh, the car can do some work on this field, but the rest is about the driver, the user experience, like how they charge the vehicle. Like because if you charge the vehicle when the sock level is really low, the battery level is low, you have certainly more losses. So it's not the same when we charge the vehicle every day, like a small portion, like if from suppose if you charge from 95 to 100% every day, or 90 to 100. In the end, you have less losses than if you charge like from 20 to 80, 20 to 100%. So depends a lot how the user charge the vehicle. Yeah,
Okay, yeah, I
and
think that
then
is
but
answered. And he showed a graph
all,
also.
yeah, always we can work with temperature, like improve the temperature when you charge the batteries, some active cooling, or yeah, there are different techniques.
Yeah, so like, yeah, I think that's the questions. If somebody wants to ask, you can just unmute and also ask. Okay, and Tatiana, once again, I thank you for joining with us, and it was really wonderful to see you and even to listen to your experience in the field of electric vehicle. And in further also, I'll be disturbing you for more lectures, but not like might be in a year once. Okay, so please, we want
Next time, please, a bit later.
I know that. So, like, the main thing is, say, we want to get some input from the industry, what industry wants. Okay, accordingly, we can now. I got many things, like, talking to you, I could understand that even MATLAB and other things is used in industry, but we can go for this at like in the MATLAB also, like the electric, mechanical, the electric, the temperature models. We can make our students design so that like it will be easy for them to when they go to an industry, like you people may pick them. And I saw that your company is also hiring many engineers. You have in LinkedIn, you have put
Yeah, yeah.
many
So
openings.
Sweden has a very hot market, like there are lots of demands on research and engineers, and yeah, the market is really hot, like in terms of jobs here,
Yeah, and
because
mainly
lots
the
of things
electric
are going
vehicle
on.
area also.
Mm.
Yeah. That's what I saw. Like last week, also, he had put many openings in your company also. So that's why I found like our students have to be equipped with all these tools. And really, it was really very wonderful talking to you. And once again, I thank you for joining with us.
No, no problem. Thank you, and thank you for the nice opportunity. Yeah,
Yeah. So
and
and convey
good
my
luck in
regards to
your
Cynthia and
research.
the little one also.
Mm. Okay, thank you. Bye bye.
Bye. Bye. And participants, the next lecture we had from ABB, which I was also looking forward, but Sir had a sudden meeting being scheduled. So now we have one more expert. He will be joining us. It's from Altair EV. Okay, so they will be joining from like 11:30 to 12:30. They had given a schedule because it was in very short notice. Just before our lecture started, I talked with them. They were also calling me. I will just like, so now you can take a short break and sharp 11:30. Before that, I will just talk with them and I'll arrange the lecture. So sharp 11:30 we will meet. And like ABB sir had given a schedule on 9th. Let me plan out in case, because all those schedules we have already done it. So afternoon might be we can shift our valediction, it may take only less time. So we can have from 2:30 to 3:30, we can have sir's lecture, and from 3:30 we can have a valediction. Okay, so I'm just planning out how to have get input from sir also, because mainly we want to know like in which areas we want to work based on the industry experts input. So now you can take a short break, and sharp 11:30 please join, because 11:30 to 12:30 you will have the lecture, and after that again we will take a break. Okay, so now you can take a short break. I think our expert has joined from Altair. Synergetic sales, yeah.
Yes, ma'am. Good morning.
Yeah. So good morning. I'm very sorry. Within a very short notice, we had to invite you. But really, thank you for accepting our invitation. And you are here to give the industrial perspective on the electric vehicle research that can be done, and with your software, and for the participants, Chandra Kumar sir. Sir, you're Chandra Kumar, sir, because I didn't have time
Yeah,
to.
yeah. No problem, madam. Very good morning, all, and probably I can give the
Yeah, sir will
introduction.
be a better person. We have Chandra Kumar sir with us, who will be delivering the lecture now. And sir, for your kind information, this is an STC on research scope for electric vehicles, and it
Okay.
is a 5 days course. And almost we are on the third day. We had experts from IITs and different industries. Today morning, we had an expert from Sweden
Oh,
who
great.
had worked with Volvo, Scania, and many other
Oh,
industries, who
nice.
had given us insight on what industry wants, what are the open source softwares available, and how what are the problems on which they are working. And he
Okay.
also was telling about different softwares like the Altair and the Answers and many other softwares they use for electric vehicle thing, and even HIL and other
Yes,
things
yes.
what they are using on. So it
Okay.
was really very interesting, and I can tell you like around 22 different institutes throughout India has connected online, and
Okay.
they have their faculty and researchers and master students who are sitting in their place in the conference, also different other places and attending. And apart from that, around 70 to 80 participants have directly online connected to NITR, and they are all faculties from different engineering colleges and diploma colleges. So
Okay.
now I hand over the session to Chandra Kumar sir.
Thank you so much, ma'am. And yeah, it was probably we interacted in the past with the Lavish during our with you and a dean of your electrical department for setting up the EV lab. And my engagement with the NITRPTR is very special learning for me because I'm typically an electrical person, but got to work on opportunity on a digital twin, on a vertical wind turbine. My contribution and driving a different teams, not only I contributed on the electrical side on the data acquisition, but not only data acquisition, it is also about acquisition of knowledge, like applying Knowledge Studio. We have a tool called Knowledge Studio, which is on the machine learning and AI platform. How you acquire data, you process that data, and then you apply that onto the simulation virtual world. So, in terms of working on a project for almost 6 months with Dami sir from mechanical department. So it was a great
Okay, sir.
opportunity to work with him and the research student over there, and they published the paper during our conference in September. So that
Okay.
was the engagement which we did in the past with Altair Association on the mechanical team. But now my talk today, I want to associate with the electrical department because NITRPT as being a pioneer institute for all NITs and IITs as a pioneer in terms of setting up advanced lab and course contents and changing your way of thinking, what setting up your gap between the industry and the academic gap you're trying to bring in. So that is a greater thing which I want to highlight. So with that note, I will probably quickly go into the talk because I have another meeting
Yeah,
which
I
was short
know.
notice. Yeah,
Yeah,
I'm
thanks,
actually
sir. I know you had another meeting also. You wanted to
yeah.
from 11, but still you
I
had,
don't want to use this opportunity of meeting all, and then it's like see whatever my learnings and how our
yeah,
tools can be play a major role in EV. That was the whole talk. So let me directly go. I'll try to keep my presentation for 40 minutes, and then probably we can
sure.
have a
Take up
Q&A.
questions. That will be a
Yeah,
better thing, sir. Since you're working in this field of AVs also, that will be
yeah,
very helpful for us. Thank you, sir.
yeah, ma'am. So can you able to see my screen, ma'am?
Yes, sir. Yes, we can see it. Yeah.
Yeah, sure. So let me give a quick introduction. So my name is Chandra Kumar Chandru. So I work as a senior application specialist for a group called a Math and System Group. In that we have entire portfolio of model-based design and development. So today's topic, I'm trying to talk on electrification, how the system modeling for EV applications. So before that, probably I'll talk about a couple of slides about Altair. Altair is US-based MNC. People would have not known about Altair. Altair is quite popular, especially on the finite element-based, especially all the mechanical CA engineers will be knowing globally. But going forward, Altair has length and breadth of technology, which is handling multiphysics, be it low frequency, high frequency, computational fluid dynamics, plus also model-based design. And we are also now moving into data intelligence. So basically, we have DA switch and also IoT and so on. So that is our the wide range of portfolio. We are addressing entire segment of markets, and we have around 15,000 plus global customers, including Indian customers, and our revenue is around 532 million till 2020. And our presence is there towards globally in all 25 countries. We have 86 offices, and we have around 150 plus products with the Altair products plus partner products. And our company became public in 2017, NASDAQ listed. So this is a quick introduction about Altair. Probably people would have not know about Altair. And what is our vision? Our company vision is to basically to transform the enterprise or decision making by leveraging the convergence of simulation, data driven design, and high performance computing with artificial intelligence. So that is our vision of our company. With our portfolio, we try to use our vision to our product development. So to talk about today's topic, how the evolution of from a traditional fuel injected electric fuel injected powertrain vehicle to electrical injected powertrain vehicle, how we are moving in. If you look at the evolution of complexity moving from a traditional product where we majorly deal with simulation validations, from one decade to another decade, there's a lot of technology transition happening where we move into a more optimized product in terms of reducing the cost and mass and so on. From the optimized product, we move one step ahead of smart products. When we talk about smart products, it's all about embedded system, control systems comes into picture, and a smart vehicle. From a smart, we talk about connected products where IoT and cloud analytics comes into picture. And from there, we talk about another technologies about digital twin and digital thread. How you can do your predictive prescriptive maintenance in terms of connecting your physical device with the virtual design for your better product development. So this digital twin is a buzz where people talk about. You talk about electrifications. I have done one use case with respect to e-mobility digital twin. Probably I can show you during my presentation as well. This is how the evolution of technology evolved over a period, and then. Looking at this slide, how our technology is different. For example, you take electric motor. So electric motor has three different fidelity of models. One is 0D is nothing but your first principle mathematical equations. And from the Park equation where you have 1D, that is where you do signal-based, physical-based modeling of representation of a motor model. And then in 3D, we talk about detailed electromagnetics, where we talk about flux, which has the tool called flux, which is electromagnetic tool on low frequency, where you can design by giving all the winding property, magnetic property, material property. You try to do all the advanced electromagnetic studies. That is possible. So by having this in the slide, so we have an advantage of different fidelity of model like 0D to 1D to 3D, but you can also have a combination of a 1D plus 3D as well. So it holds good with respect to mechanical systems or electrical and electronic systems. That is the unique differentiation of what we address in terms of 1D or 3D. Yeah. Just a moment. It's getting stuck. I don't know what happened. Just a moment. Okay. So let me, sorry. So what are the product lines? Am I audible, right?
Yes, sir.
Yeah, I'm sorry for that. Altair has a different, as you said, like other representative from Sweden, he spoke about different tools available in the market, and then how these tools are applied. So what I'm trying to convey on this call is that with the help of our Altair suite of solutions, how you can do your product development for electrifications. That is what and what are the different areas you can address. So these are quite interesting products. One is Activate, which is for multi-domain system simulation tool, and Compose, which is for developing scripts in different languages like Python, R, and OML for algorithm development. And we have Embed, which is for firmware development, and PSIM. As I guess PSIM probably people would have worked through in their curriculum, especially during in your power electronics side, especially. So PSIM is a dedicated tool for power electronics and motor drives, which is acquired recently by Alter. And I, prior to joining Alter, I was with PowerSim. So that is the background which I'm trying to set up. So these are the, and motion solve is for vehicle multiple dynamics basically. So these are the product lines which comes under math and system. So coming to our topic today, with respect to solution for electrification, Alter solution for electrification. So basically we do design and integration of e-powertrains, which goes from typically, if you look on the top side where we have typically mechanical systems like whether lightweighting like C123 concept, and also we do crash, NVH, fatigue, and also we have fluid and thermal management, and these are comes under your mechanical side. When it comes to purely electrical, so where we handle power electronics, power electronics is a major, like where we have battery design, power electronics, and then motor design, and also the firmware side where we do electronic system and firmware development, and also the system modeling and vehicle integrations. Okay. So, hello? Hello? Am I audible, right?
Yes, you're audible, but
Yeah,
some
sorry.
sound was coming, but it has stopped.
Yeah. Actually, power got down, so that's why. That's the
Okay.
reason I just want to cross check, ma'am. So,
Yeah. You're there. You're there.
yeah. Okay, fine. Okay. So regarding the power supply as an application, so if you look at electric vehicle, there are different subsystems like vehicle control unit, engine control unit, onboard charging stations, and so on. So power supply plays a major role, whether we have low voltage, medium voltage, high voltage range, depend upon the capacity. So probably power electronics is there in almost all the subsystems. Being EV, it is a main primary driver. Basically, it converts your battery input DC to AC to drive your motors, and then also the controllers. So PCM plays a major role in doing your power supply designs, where we provide schematic level for analog and digital circuit. We have PCM. For doing thermal level, we have SimLab. For doing board level, component level thermal analysis, and for anything with respect to PCB fabrication, we have a tool called Polex. So these are the tools which is there for complete power supply design with respect to electric vehicle, whether it is a passenger vehicle, commercial vehicle, or two-wheeler, any application as such you can use for power supply applications. Okay, moving from power supply applications, like how PCM can simulate. So if you look at this particular diagram, this particular slide, which gives you more clarity. See, you have the plant model, that is a power circuitry as input DC. You have the converter model or inverter model, and then you have the plant as the motor model, where you can have a detailed 3D model as well as a mathematical model. It's your choice. So you can bring in your flux, and flux is our in-house tool for electromagnetics, and G.A.M.E.R.Z is also a third-party tool which can be linked with PSIM. And you can also apply some complex mechanical loads as well. This comes on the plant. When it comes to controller, so controller can all the Park equation, Clark equations, all the control techniques, whether you want to sensor or sensorless FOCs, maximum torque per control or field weakening control, and so on. Those can also be coupled with Simulink. You can couple with Activate. You can couple with Embed. So these are all the different choices what you have where you can do the co-simulation. That is what you can do today. So apart from power supply as an application, moving on to the next solution is motor applications. So complete motor drives. So going from motor and multiphysics. So if you look at on the left-hand side, this is a complete story which talks about the multiphysics of motor. So we have flux motor for doing motor design. Once you design the motors, and then you need to do the electromagnetic studies, then you use flux. From flux, once you do, you need to, for example, you want to do a NVH or a vibroacoustic studies where we have SimLab. And then we want to do about optimization of your magnets or enclosures, then you have OptiStruct. So this is our typical multiphysics integration for motor design. You take only as a motor. I'll give a project to you. For example, this is my spec. For my vehicle, this is my speed I want, maximum speed, rated speed, and then this is torque, and this is what the spec. This is my power rating. So based on this, you need to design the motor, which is more efficient, performance, cost, weight, everything in terms of efficiency. I want to design a motor. Before you prototype a motor, you need to do the tools to design it. So here is the tools to do for you to design it. That is the first one. From there, once you design the motor, you need to study the performance of the controller. whether I want to do a speed control or torque control for traction applications, then I need to do the motor controller design. So that is done by using PSIM. Once you design the controller part, then you need to do the complete virtual validation with the different from a battery to converters to motors and the controllers, how these driving cycles and also the duty cycles and PWM effects affects and the performance of the motor, that you can study. Once you're done with that, then you try to see the HIL, that is hardware and loop simulation. That is with embed, you can do real time. You'll have a real motor, real controller, real inverter, and then controller where you'll be doing a hardware and loop simulation. That you'll be doing it. So today, with the help of Alta Solutions, you have different tools to do it. You can just see the names. These are the domain names, and then the tools used for to do the domain. So motor design is a domain name. You can use Flux Motor is a tool to use with Alter. Electromagnetics, we have Flux. CFD is a competition fluid dynamics. We have SimLab to address that. Structural analysis, we have OptiStack. For motor control design, we have PSIM. Code generation, we have Embed. Activate for system simulation and controls. That is the solution. So Compose, in a quick introduction, Compose is basically a scripting tool where you can use Python, R, and different programming language to develop your algorithms. And you can also, it is syntax compatible like MATLAB and Octave syntax. So you can take their legacy code and you can work on doing signal processing, solving any complex math, and also addressing any developing any algorithms as such for any applications. You can use Compose for developing algorithms as well. So here is a user interface, how the Compose user interface look like. So it has toolbars, it has browsers, it has scripting windows and plot, and OML and Python interpreter windows is there. So where you can look at the Compose user interface. This is quite similar to your MATLAB. So you can see. And then moving on, as I said, it is syntax compatible. Look at here, this is a MATLAB script, how you can rename that script and you can reuse them in the Compose environment. So this is a simple differential equation, which is a second order differential equation, which you are using ODE 45 functions. And you can look at the scripts which supports all the data types and or whatever the data types which is used in the MATLAB. So it is quite same in terms of using labeling, everything. So it's the same code you're trying to reuse. You're trying to rename that from M to .oml, and then you are running the model and opening that in the Compose environment. Okay, this is a script which you opened. Same script you're trying to open it in the Compose environment, and you're running the model. So this is how any scripts, if any function is missing, probably you need to create a custom function. But more or less, you can use the same language, same script. You can use it in the Compose environment. So moving from Compose to Activate. Activate is another interesting tool for that is basically like a system integration platform and combining 0D, 1D, and 3D. So to talk about the tools, how this can be used for multidisciplinary system integration. So which goes from parameterization to block level modeling. When I say physics based, where you have electrical, mechanical, thermal, hydraulics, multi-body dynamics, all these physical block sets are available, like where you can represent like a spring mass damper system, and then where you can use. And also we have electronic circuits where you have analog and digital circuit designs can be done. And you also have ROM AI, that is reduced order modeling, which is for where you can use AI and ML platform as well. And these are all comes under 1D block libraries. When you want to move from 1D, you can do co-simulation with our traditional 3D tools, whether it is Flags or MotionSol or AccuSol. You can couple with them with the 3D tools. And also you can do with third-party tools like FMI, which is functional markup unit, which is where you can typically connect with third-party tools if those tools are FMI compatible. And not only that, it also has the connectivity when you want to send the data through UDP protocols, TCP/IP, all these different protocols and MQTT. We can pretty much do this. So probably I'll just show whatever the capability, I'll show the use cases as well. So this is how to take up your legacy models, and you can load your MATLAB files, and then you can, the previous slide is all about importing your legacy models from Simulink. Import and export option is possible, and you can just load your MATLAB file, this is a script file, into our Activate environment, and you can work on. So that is one thing I'm just trying to indicate. The next one is motors. You can represent three different form. One is Park equation model, lookup table format, and then also the co-simulation. So all the three methodology where you can look at the motor. So this is a typical use case for a battery-driven electric powertrain model. How you can typically do that is from a driving cycle to driver. You have different subsystems based upon different driving patterns. How you can overall look at the performance in terms of efficiency, battery state of charge, the health of the battery, and so on. So here is the example which basically talks about the actual speed or the design speed, and you can look at your vehicle range and then the battery state of charge and the instantaneous motor efficiency, and also look at their motor speed torque characteristics. So this kind of virtual validation you can quickly perform whether in any kind of range of vehicles. You can test of different subsystems are there with respect to battery driven, how you're gonna see. So I have many use cases. I'm just trying to show just to keep in time. I'm just showing a few. One is this is from Porsche. So how Porsche has used whatever I showcased, right? So in terms of electric vehicle development, they used 0D, 1D, and 3D in terms of concept design to detailed design to system integrations. So when it's talked about detailed design, it's all about stiffness, strength, durability, acoustics, system controls, thermal. All these aspects are typically they integrated and they completely did it from a concept to system integration. That's what they use our tools. And this one use case which I want to talk about is the recent Switch Mobility is a company where they're using our tools, accurately predicting our electric vehicle range using our system level approach. So I'll just probably play this video. How people use our tool is what I'm trying to say.
Electrified section of Ashok Leyland and the Optare in the UK. Range prediction is the hot topic. Since the battery electric vehicles doesn't have as much range as internal combustion vehicles, we needed to understand which parameters affect the battery range and its performance most. Altaire's responsibilities with the project was delivering proof of concept simulation work, which has alignment with the real life data. For that, Switch needed to supply as accurate data as possible, especially for our in-service vehicles and the real-life applications. We supplied them to Altair, and Altair used those data to create simulation aligns with our real-life data. When all that comes into place, you basically generate a new system, including all the subsystems, to basically create a digital twin of the in-service product in the simulation world. Before we start with this project, we were expecting mass will be one of the vital parameters that we need to focus on. But apart from that, we were a little bit unclear how much the aerodynamics or the rolling resistance will affect. So this project helped us to understand relatively with the higher and lower speed which parameters come into place.
So this is one which I want to indicate. Probably I don't know whether you are able to listen the audio, but this is one use case which I just want to show with respect to an EV startup, how people used our tools in terms of digital twin and other things. So in terms of using our technology as a reduced order modeling for predictive and so on in terms of vehicle range as a system level approach.
Switch Mobility considers itself
So
as a mature startup.
these are the things in terms of opportunities for comprehensive modeling, understanding the most effective parameters, reducing prototyping, saving time and cost, accuracy, a wide range of tools and expertise. Okay. So that is on the Activate side. Moving on from Activate to Embed. Embed is our model-based embedded development framework, where to look at from a concept to end productions, from where we can do design, simulate, analyze, and also generate efficiency code, where you can put that code onto the firmware. We support around 1,200 plus microcontrollers. If you look at Embed, in Embed we support generic MCUs, Raspberry Pi, Arduino's, ST Microelectronics, STM32, Texas Instrument like Cortex M3, Delfino, Piccolo. All these are the different series of microcontrollers. We do code generation for those hardware peripherals. Where when I say peripheral, it's all about ADC, PWM, all the different things are available, so where you can use them. And we also have add-on models which has pre-built motor diagrams are available, built-in diagrams, whether it is simulation or code generation diagrams are available. And you can also couple this with Embed with PSIM, and FMI is compatible with PSIM and Embed. So we also have an Open Vision library. It's part of Embed. For anything, for any ADAS application, you can use the Open Vision libraries. And state chart is there. State chart you can use for simulation and also for code generation. So that is about the capability which can go from a concept design till the HL hardware loop validation. So how the workflow is. So where we do code generation and HL prototype. So on the left hand side, you do complete simulation. Once you're done fine with your simulation, then you go for code generation, and then you go for the implementation on the hardware targets, like whether it's ADC, CAN, DAG, IoT, I2C, any kind of these peripherals we support. Quite deep peripheral supports we do. And then and we also have an add-on model library called eDrive add-on model, which has a pre-built 175 built-in motor diagrams are available, where whether it is any kind of motor types, maybe motor drives or supported drive types, whether you want voltage control, current control, sensor or sensor FOCs, all these diagrams are available, and you can quickly test your motors in a real-time environment. So I have proof and evidence how we are used. Okay, so as I already said, the model-based design and process, so which goes from a concept to end product, which has different stages involved. First one is called the model and loop, where everything is virtual. You try to simulate on the PC. Next is software and loop, where the plant model will be like a DLL file running, and then the controller is in the PC. And then the processor and loop, where we have the plant model virtually there, and the controller model will be running on the actual firmware. That is your PIL. And then moving from PIL, we have hardware and loop simulation, where everything is physical, plant control everything, and you try to develop the algorithm and testing it on the firmware. That is the HIL phase. So this is how the MIL will be look like. So model loop, you'll have the plant model, inverter model, and then the controller model here, and you can look at the response, how the motor response, like torque, speed, and everything looks like. And then from there, you have the co-simulation. The PSIM is also possible, where you can bring in your power electronic circuits into from PSIM to embed, and you can simulate. That is also possible. And then this is SIL. So where the controller auto code generation model is there as a DLL file, but the plant, like motor, controller, everything is there. The inverter and the motor model are there in the virtual side. So this is about your SIL. So PIL, where plant will be virtual, but the controller will be real time running on the firmware. So that is your processor and loop simulation. Hardware and loop simulation will where you will have the real plant model, real controller. You can just look at the motor, controller, inverter, everything is there. Where you develop the complex control algorithm, you do auto code generation, and then rapidly test your control algorithm on the firmware. That is your HIL, hardware and loop simulation. So here another add-on is digital power. Anything you want to do on power supply designs, like converters, inverters, that you have, that is also pretty much doable, and you can use our add-on model called digital power designer model. So these are the recent work which I've done. This was a talk which I had a word with Madam last long back. Like this was one EV lab we did set up, running different ranges of motors. One is 1 kilowatt PL DC motor, 3 kilowatt, 900 watt PMSM model. So how we can use our embed tool to spin or drive this model in real time. So whatever you can do virtually, but whatever you do virtually, same thing you do to do a real time implementation. So these are the few snapshots which I captured for what we executed. And there's another lab we set up for motor control itself. You have an up wheel motor, and then you have the inverter controller card. So different range of motors, how we gonna help them in terms of setting up the lab. This is another one. So these are the different flavors what we worked and tested, especially so we can work in the same passion. So that is what I'm trying to indicate you. And then from there we have another recent work. How I worked with NITTR for vertical wind turbine digital twin. This particular project I worked recently on e-mobility digital twin. So we can probably we can have same setup if any of your faculty members want to wish to set up the same, whatever the previous slides and this, we can pretty much support you on this. So here we have this as a PMSM model, and you have a controller card. This is basically a retrofit for your Activa or any DO vehicles, right? You can fit this motor and the controllers. So what we are trying to do, e-mobility digital twin, is why do we do this? The message is to our prospects and customers to keep control of our products on the field. It's not too complex, and you already know do some or many in the silos without connecting in real time. So how we try to offer a complete end-to-end digital twins. So these are the steps what we followed. So you look at here, this is the actual model which is running here. You can just see giving a throttle, running the model. So what we're trying to do here is this is a PMSM model, 5.5 kilowatt electric motor, and input is 48 volt, 44 ampere hour lithium ion battery pack, and we are collecting the data and through a canvas in real time. So through embed, and then we collect the motor torque and motor speed, and then we push the data to cloud. When we push the cloud real-time data, when you're driving the vehicle, you collect the data and you push that to a cloud, and you're applying that onto a mathematical model. We have applying your motor torque and motor speed to your electric motor, and the inverter is there, and then in turns, by estimating the by input from motor torque and speed, you're trying to estimate the state of charge of the battery. That state of charge of the battery is applied onto a real-time streaming tool like a dashboarding called Alter Panopticon, which is basically to do a real-time streaming to look at the parameters. So this is the physical side of the digital twin, and then this is a virtual side. Virtual side, digital side, we use simulation tools. So to connect between the physical and the digital, we connect the data to cloud through MQTT. So we collect real-time data from a motor, current and speed, and we push that data to on a cloud, and then both the PC, the physical system and the virtual system is Wi-Fi connected. Then we are pushing it through MQTT, and then you are looking at it. Okay. So how we collect data is this through the CAN. So this is a peak CAN analyzer. Basically, we do real-time data acquisition. One is through sensor, you can collect data. Another one, because we already telemetry data is coming through CAN. So CAN is a commonly used protocol for automotive side. So we collect all the data like motor speed, current, torque, all these parameters are collected, and you can in a real-time environment. And then that is what we did for the e-mobility digital twin in terms of data collections and processing and so on. So this is another rapid EV traction motor for control for 800 watt PLDC. This is an upwheel motor, and you have an inverter and the controller card. Same way, this also this particular setup is there in our office. Basically, this also we did the sensorless FOC field oriented control for this motor. So these kind of competencies we have with respect to EV side. Okay, and this is on the battery management side. With respect to battery management systems, we can also individually see this cell temperatures, currents, and voltages, whether it's lower or higher, a battery pack, state of charge, health of the batteries, and so on. All these things we try to see, and based upon the range of voltage level you work on. And how do you deploy? We have software GUI based and hardware links to control and then see the overall BMS battery management systems. So this is one use case which I have from Teresa, which is basically it's also a startup company on a rapid prototype of motor control algorithm that is for EV powertrain packages. They use embed and digital power for doing motor control implementation and also for battery management systems. And then they given their testimonial. So it is there, which is how in terms of code generations, reduces the risk of human errors, replacement the HIL systems, and reducing your development time almost 60% from simulation to hardware deployment throughout the model reuse. So that is how their value by using our tools. So just to summarize the takeaways of Embed and the overall solutions what we offer. See, Altair provides you an end-to-end solutions with respect to electrifications. So electrification has a different subsystems, whether you have battery design, BMS, motor design, motor control implementation, or inverter design, and also the or say you talk about the control implementation like HAL, we have a complete suite of solutions, and also the co-simulation with 3D to 1D, and also mechanical side with respect to optimizations and NVH and lightweighting and so on. We have completely have the end-to-end solution. That is the summary which I want to convey. So probably I can take up the questions, and if you want to see the live software demo, probably I can show you the demo as well. So yeah.
Yeah, till now, if you have any questions, you can ask participants, and we would be liking to see a demo also, sir, like something related to EV.
Yes, madam. Yes.
Participants, by the time sir is setting it, you can, if you have any doubts, you can ask.
Okay. Okay, let me show you interesting things. This is a tool which I'm probably please because I don't know whether how fast I went, but probably we can have one-on-one session later as well. Please let me know if you have anything I can answer.
So, sir, for your software, like say in case many participants are here, might be their institute now they can't go for effort for this. So, is there any student version where they can start with, and then might be once they have practice and they are well honed and hands on, they can go for your product. So, is there any other or any option there you have any students version or on which they can start working with?
Yes, ma'am. We have student version is available. Probably people can visit alteruniversity.com. So where I'll just probably show you the portal. where they can go. Students can download Alter University. If you go to alteruniversity.com, so where you have this, people can get 1 year license where they have to given the right information. So you have online courses, support forum, learning libraries are there. Okay, so you can get all the contents available here. For example, you type embed, it will come. You just type, so you'll get all the relevant materials here available. Okay, so you can read more about it, and you have all the video. Students are there already enrolled. You can just log in, and then you can get the license request also from here. The free student edition, free ebooks, online certifications are available. Student competitions are there. So you can probably go through this website. I can
Okay,
just,
this is really very useful. I think many teach faculty are also there, and I think for
I can just put
hardware
this
and
in the
all
chat.
this,
Yeah, I'll just put this in the chat probably.
yeah, the link if you can put it in the chat. Like it is Altair University, so it's simple. Yeah, thank you, sir.
Yeah, ma'am. Actually, I'm having a one question from the sir.
Yeah.
Sir, actually, you just talk about that for this twin system. So basically, we are also working such type of system. So exactly, basically, we just want to know. So what is the exact component we required? Let's say in a hardware or in a software mode for developing this twin system in our lab or
Okay. So yeah, actually, let me show you what I developed. So this was to
yeah.
make this simple. I just only added few slides, but let me show you what we did with respect to digital twin. And this was a recent show technology which we showcased in our conference. Uh, Let me open up the slides and then see, it depends upon your objective and problem statement. Based on that, we can just show you. This is what the complete end product what we achieved. To achieve this product, probably you can go through what are the different stages we that. This was actually a block diagram, the flow of what we did. So what we had is we should have a physical setup. From a physical setup, we need to collect the data in a real time through sensor or through any device, and then you pass on apply to the math model, and then through a real time dashboarding. That was the idea. So this was the steps which we followed. From physical setup, we collected data, pushed to cloud, and then did a mathematical modeling, and then we have MQT. So the different types of digital twin. So if you look at current technology, digital twin has a different definition. Different people call different companies have a different terminology to explain. Okay, they give their own definition. So there are data-driven digital twins, physical-driven digital twins, and also the completely math model. So there are different ways of digital twins are available today in the market, and it's all about the tool chains are used to completely accomplish it. So Altair as a company, we have tools to accomplish all this, whether you for data acquisitions or knowledge studio, AI and ML side of it. Today here we are not doing any ML side, because directly we are taking the data and we are pushing the data to cloud, and then we are applying that data onto a mathematical model of an equivalent virtual model of the physical setup we are trying to represent, and we are trying to estimate the state of charge of the battery. Imagine in your situation now, what we did is I am driving my electric vehicle, and I want to know what is the range I can travel. For example, I charge for 1 hour for full completely charged. How much kilometer I can drive based upon different driving patterns, you can try to estimate. If you don't have any indication or alarm, probably you will end up in not reaching it. So it basically gives you an alarm to predict it. So how is my state of charge and health of the battery? That gives you an indication on the dashboard. How you throttle your bike, and it has a dashboarding. You look at your speedometer, right? Same way we are trying to do this as a process. So these are the different steps we involved actually when we started working on here. So this is how we bought the motor and the controllers, and we put effort to collect the data. And this was the actual spec of the model. PMSM model, which rated speed was 3,300 RPM, 10 Newton meter torque, rated torque, and size, capacity, and everything is here. What is a 48-volt battery? Battery specification is over here, and motor specification is here. And then we did a real about dashboardings and so on.
So, sir, my one question is that so you have purchased all the component on a ready-made mode and you just try to assemble and just try to accumulate the data and just you are working on
Okay.
the data itself, huh?
Okay.
Or you are just trying to develop your own controller, your own battery management system, and so on.
Everything, whatever as you said, right? See, just tell that. See, they used our flux tool to design this motor. Okay, and then they prototype the motor. They use our software to design this. First of all, there are different stages. Let us not forget about, as you asked the right question, one is buying and fitting and then doing it. So it's up to your choice. You can use our simulation. In this case, we showed the end-to-end solution how our tools are used for product development. That is what the point I'm trying to convey. That's how you get the confidence, right? Okay, by help of our tool, you are doing a product development. So motor design and prototype is done with our flux and flux motor. Controller, we used embed. And for designing converter, we used PSIM. And overall, the product is there, up, which is physically there. From this physical device, how am I going to calculate my state of charge? That is what we did in digital twin. The purpose of this particular demonstrator is, from a physical device, I collect when I drive my vehicle, I take my input as motor speed and torque. Based on the torque and the speed, how I calculate torque from the motor current, I can estimate the motor torque based upon the motor parameters. From the torque and the speed, I try to apply this onto a mathematical model, and in turn gives me the what is my state of charge in a real time, not offline, real time. There will be some delay in the data between the data fetching and the applying, but it is happening in real time environment. That is what I want to convey.
Okay, so in the real condition, actually, what type of test basically you did in the past? Let's say for checking this all these real time parameters, because there are lots of tests, na? There, let's say in a real time conditions, or let's say in a road condition. So
Yes, see, that's why in this case, as a demonstrator model, we have taken only state of charge of the battery as one problem statement. In your case, if you want to estimate some other parameters, you can do n number of parameters for digital twin. Okay, it's all about how we are connecting the dots. In this case, three simple steps. What we are doing is data acquisition from a physical device through a CAN protocol. From a physical device, after you collect the data, you are applying that data on a mathematical model. That is what you are doing it.
yeah,
You're not doing hand calculation. You're doing whatever the physical setup you are virtually setting up in Activate as the same motor battery. For example, if you're using 48-volt battery, how many batteries are connected in series and parallel? Based on that representation, you're trying to apply this motor torque and speed. Then you're estimating it. So three steps we are doing. Panopticon is for visualization, real-time visualization like a dashboard we see. That is what I'm trying to do here in this use case. Three tools. See, embed, activate, and panopticon.
yeah.
I think sir wants to know
Okay.
further, like say if you have different drive cycles, like in the urban area, this I
Okay.
think that also you can give and see how this reacts,
Yes,
is it? And how is the
I can.
battery?
Yeah, we can do that as well, ma'am. Actually, so we have those kind of models also. I already shown you one driving cycle pattern based upon how you do it. See, this is another typical example which I want to show you. So this is a user interface of Activate. See, you have driving cycle here. Driving cycle maybe from LTPA standards or ARI can give you the driving patterns. Based upon different driving patterns, you can overall validate your what is say. See, you have vehicle dynamics, you have drive line. Okay, you have the battery packs here. So you have battery packs. Okay, for range calculation, and then you have this is the battery packs here. Okay, basically you'll have the complete bat to conversions is there, and then this is about the charging and discharging part. Okay, and then you have the nominal voltage packs are here. Okay, and then if you come out and you have vehicle dynamics, it represents as a mathematical equation. So everything is a complete virtual model what you have here. And then the driving cycle, we have the desired speed and acceleration is converted to vehicle power, required power, and road force required. Okay, and then you have the driver model is this, and then the driving cycle. So driving cycle basically you have the CSV file. So probably you can load your CSV file. This is a file which comes from WLTP standards. You can just load this file as well. So this is a pattern. So time versus cycle and cycle acceleration. You get the speed, accelerations, and you're trying to load this file as an input file. Okay. If you have these different patterns, you can quickly estimate and then you can assess. So that is what I'm trying to show you here now. This is a battery-driven powertrain model. You can run here. You can completely estimate the state of charge of the battery, see the vehicle range, the battery state of charge. So 0 is 1 means 100% fully charged. So you can look at the motor efficiency, and then you can look at actual speed was the desired speed, and then the motor speed torque characteristics. This is a virtual validation. Okay. See,
Okay.
now
One
another
more.
interesting thing. Yeah, ma'am.
Yeah, sir. In case, say, I don't want to work on the whole thing, but might be I'm working on the power electronics side, the converter side, and like I have designed my own converter and I'm trying to fit it here. But how much like the other like the vehicle dynamics, the train, drive train, the battery management system, all those things, is it equivalent to the standards of what companies are actually using? Because I have done only work on my power electronics side. So how can I validate this my system with the real time system? Like in case I'm not having the whole
Okay.
system,
Okay.
I
Very,
just
very, yeah,
have
ma'am, very nice. Very nice question actually. So let me answer you because in the given time I need to show you things. So that's the reason I'm trying to, because I'm also from power electronic background. So for example, you want to do an onboard charging, okay? Power supply design. Go to power supply suite. For example, I want to design an off-bridge resonant LCC converter. I just unpack this. So as you know, right, why people go from normal power supply like buck boost to resonant converters? Any reasons? I'm just generally asking a question that why people go for resonant converters, not the typical topology like buck boost, flyback, or any kind of other topologies. Any reasons?
To avoid harmonics.
Okay, one more. So probably I'll answer. So because of the switching losses, basically for short switching, basically when you go for buck boost, these are hard switchings. When you go for these off resonant converters, right, it's basically a soft switching. Basically, you will reduce your switching losses, switching and conduction losses. So that is the importance why they have the resonant tank circuits. That is what you see here. Okay, these are the resonant capacitors and inductors, and you have the transformers here. So the beauty of this topology is how quickly you can design your power supply onboard charging station. So let me fit in this. So what we have here is you can update your steady state curves here. See, I give my input voltage 270, rated voltage, a minimum and maximum, and output from input 300. I want to step down to 24 volts, and power output is 500 watt, and the resonance frequency is 20k, 200k. And just you want to calculate it, just come down, you calculate it, you get all the calculated parameters. Can you see here? This is the calculated parameters which automatically calculates for you. This is the beauty of the tool. So once you calculate here, so you're given all the input parameters, output parameters, and the operating condition, update the file, and then you got the updated file. For example, you updated this, okay, you got all the parameters like output parameters, controller parameters, everything is calculated. Now you can quickly run the simulation, and you can look at your output voltage. Output voltage is designed for 24 volts, and you can look at the output power. And you want to look at the power, I can add output voltage multiply into current. I want to look at the current flowing through it. So let me run the current and enable this. So I'll make this current flag 1. So I'll just say the run the model. Output power was 500 watts, so I'll add output voltage, multiply this, add my current IR7. Okay, add it. So it's calculating. So this is output power. So you can calculate my values here. So you can look at your RMS value. So you can look at the output power. Okay. So it is 500 watt. Can you see here?
yes, sir.
Okay. And you can look at the output voltage, which is for 24 volts. And look at all the parameters. You want to look at the switching frequencies. You can look at your frequencies here. Okay. See, you can calculate what is the switching frequency you can range. So for example, you want to zoom in, you can zoom in the values, you can fit in your Y values, okay, and then redraw, come back to original positions, and then you can do the post-processing here. So this is a quite very interesting tool in terms of doing your power supply design basically. So recently I worked on this project for one automotive OEMs, and the results, whatever I'm getting here is 100% matching with the hardware results. And I can do a core simulation. Amazing features are there. This is about only the power supply. Okay, so you can look at the n number of parameters. What is the switching frequency? What is your relative frequency? You can just compare. You can just see here. And if you vary your parameters, you want to compare the results, you can just keep here and you can look at the difference here. So bearing, you can fine tune your parameters based on that. Okay, you can look at the output voltage is 24 volts, and you can look at the switching frequencies around 160. You can just look here. Okay, the ranges you can compare between this point to this point range. What is the frequency? Okay, so and then you can look at you can view your data, view your data points. You can view it. Okay, so this is about the power supply. Same thing, I want to do a motor control design suite. Just click, I want to design an interior permanent magnet PMSM drive. How quick you can design here? You give my input voltages, switching frequency 400 volts, and then what is my load, torque, and then moment of inertia on all the motor parameters here, poles and everything, and the motor controllers. Update files, You get all the motor parameter updated with all the motor control, like what should be my PA gain, time constants. Instead of you manually doing it, tool automatically does this. And this is your input, this is your inverters, and your motors are there, and the load is here, and then the controller part. So this is a controller part. So when I run this model, you can look at your currents flowing through the motors, actual speed was a reference speed, torque of the motors, how dynamically, how fast you can do. That is the beauty of this tool. And a lot of use cases, testimonials are there. You go to video tutorials, case studies. You have case studies on flyback power supply, 20 40 watt power supply, application notes. You can go. You can look at here onboard chargings for different ranges are there. So run SimView. When you run the SimView, see, look at the currents. These are the three-phase currents. And then you want to look at your actual speed was a reference speed. You can look at here. And then you want to look at your torque versus your speed. You can look at that. Okay. Now you can just look at, you want to compare this, and on y-axis, you can compare this torque versus your speed characteristics and look at your speed. If you want to zoom in, so you can zoom in and look at, and then fit this. So you're fitting these values here and then seeing the speed torque. So you can measure the values. Is it fine?
Yeah, yeah. But my thing is, say now we have made a new converter. Now I'm just asking, when you're putting it in the full EV model, which you showed, the mechanical and all the electric vehicle, the drivetrain and everything. So are these standard models which are already existing EVs of existing EVs of, say now for like Tata Nexion, I want to just do I want to do a conversion. So do you have any standard EV models already like in the market, the models of such things?
No. You can build it actually. That's what, see this tool is not like ready-made the vendor, because no, for example, I work with one company. Those company design, I cannot use them, right? It's a basically NDA one. You can work on a similar range and patterns, and you can completely overall integrate it. See, as I said, you want to work on inverters. See, the different level of inverters are there. Whether you want to do T-type or NPC or now what do you say, like normal PWM, space vector PWM, or IGBT based, whether you want to calculate thermal loss. See, this is a simple inverter.
Yeah.
Okay, IGBT one, single phase.
Yeah, so like say I could understand the inverters according to the standards, we can just do it for
range, whatever, because you can give the manufacturing data sheet also. Click on here, you go to thermal, you can go ideal level, actual thermal level is also there, where you can calculate switching and conduction losses. It's an amazing tool actually for power electronics design and analysis, right? I'm second half, as I said, right? I'm going for a meeting is to show. I cannot show the data, but I'm gonna implement it on the TI hardware. So this is for Infineon. Say, okay, sorry. I just want to show you the schematic of it. So,
sir, any example related to BMS system, battery balance system?
Yes, we are there. Let me show. This is the last calculation for six pack IGBT. So this is an inverter model 6-pack. See, you have a lot of vendors, different vendors like Infineon, Semicron. You can add different database here. Basically, there's a total loss and case to sync and
yeah, so that is what I wanted. Like you have of different vendors also the data sheet.
Yes. See, go to device database editor. You have the complete vendor here.
Hello. Sir, are these models available already?
Yes. Of course, everything is available. Madam probably will have one-on-one call, because my domain is also power electronics. Probably all the faculty, because ma'am is interacting. I'm indicating ma'am. So overall, there are
No, I am representing NITA Chandigarh, but the faculty here who are connected are from different colleges. So those people who are interested, I can give you your numbers also. Sir. Okay, so you can just mail me, because many people are asking and I am also not sure who are the ones interested. But for some of the nodal centers, I can give coordinators number to Chandru sir so that he can contact them. But if there are NITA participants, please contact me so that I'll try to give, I'll give the numbers and contact.
Yeah, probably this is a quick call. I'll answer everyone, but see, this is a database what you are asking, ma'am, like ABB.
Yeah, that's the thing. I just wanted to know. So for different, you have databases of different other companies.
Yes, you can add also. You can add your own device.
Yeah.
Sorry, sir. I'm sorry, I missed it.
Yeah, I think you can answer him. Who was that, sir? Please ask, sir.
Sir, I am Dr. V.B. Patel.
Okay.
V.B. Patel, sir, is there? Yes, sir.
Sir, may I have a link of this student version, sir?
That is in Altair University. Sir has already shared the link.
Yeah, it's in the Altair University.
How can where we can find out this, ma'am, actually?
Sir had
Yeah,
already.
actually, let me show us. This is a website, sir. You go to alteruniversity.com and your students, if you click on, you look at the free student
Student
edition.
edition.
You just
Okay,
click here.
okay, okay. Yes, sir.
I'll be
Yes, sir.
sharing this recording. So in case again, if you, because sir had already showed how to download the free student
Yes,
edition.
ma'am. Sir has said, but at that time I was looking about that Alter University,
Okay,
so
okay.
I can't find that exactly.
No problem. We will be giving
Probably
you
you,
the
you
recording.
all can see, students can, because when you want to access this license, there will be an authentication where student has to give their proper mail IDs, then only the license will be generated.
Institute
Otherwise, you
IDs,
will
yeah.
not get the right license. Don't give any wrong information, so that you give the proper information about your details. Official mail ID, not the personal mail IDs.
Yeah,
College mail ID,
institute
then only we
IDs
can
they have
generate,
to
because
use.
it is basically for us also to track who's using it. At the end of the
Yeah.
day, people has to use and then give a lot of paper publications, testimonials, and that is what. And in industry, we work on an official front. We try to sell it actually.
Yeah.
So there is a different ways to look at it, sir. So on technical front, see, that's why this particular tool has lots and lots of scope to work on, which has a lot of libraries, rich set of libraries like switching devices, transformers, acting modelings, motor drives. You have complete motors, renewable energy like solar and wind and battery models are there. Thermal models of database of diode, IGBT inductors are there, and then you have controllers, co-simulation, HEV design space. Many things are there. Probably you can use effectively this tool. So this is an inverter part. So you can look at your three-phase currents, and you can look at your losses, total losses, or switching loss of diode, transistors. Okay, these are losses, different losses, and then you can compare your junction temperature of diode and transistors. Okay, so this is very interesting in terms of how quickly you can validate. So with respect to thermal behavior of your device as well for efficiency calculations. So here is the PWM log. Basically, you give your 10 kilos a carrier frequency, 1 volt peak to peak, duty cycle is 0.5, and there is a modulation wave which has 60 is a fundamental frequency and 0.8 as an VM. So you're trying to generate, and the input is 400 volt DC, and then you're applying your load, RL load here. Based upon your design values, you can calculate your resistance and inductance value, and you can enable your current flag. And you want to measure your line-to-line voltages, you can add your voltage probe across this device, and then this is a wire to connect it, and then you can run the model. You can look at the response. So you rename it. This was a probe which I connected. So you can look at the line-to-line voltages. I want to zoom in the voltages. I can zoom in. So I can look at my line. So I want to fit in this. So I'll just fit in this. So basically, I can fit this curve. So it is goes between plus 400 to minus 400, and you can look the details. Okay. Redraw again, it'll come back. So redraw and come back to back position. So you want to convert this into FFT, click on FFT. So you can look at your frequency. What is your switching frequency? You can just measure the curves. So you can just click here, the frequency range you can know. Okay.
Somebody else was also asking, and
Yeah.
one of the participants want to know about the battery side. What?
Yeah, battery also we have about charging and discharging. So go to batteries, just take a battery here, and you can enter all the about battery parameters here. So this is a physical representation of battery, which number of cells in series and parallel. You can, based upon the range of voltage level you want to work, you can give in all the parameters, and you can completely understand the study about the charge state. This is a state of charge, battery current, battery voltage, and then you are calculating time hours by dividing it by 1 by 360. So this is simple one, but you can connect the batteries and you can study as well. And we also have other tools, probably because of time, probably we'll discuss. So I just showed one tool, and even we have battery management systems here as well. Battery management systems, for example, I want to go with TI. Here, this is the block which has basically all the battery management system sites are available. Right click, you can completely look at all the side in terms of individual cell voltages, currents. All these parameters can be monitored actually.
So any reading material also there to understand how to use this block, how to change the
Yes. So we have completely the battery models are available in terms of battery models, and then also the lookup table models are here, so you can feed in. Okay, just a moment. I'll receive one call. Probably I'll just take it later.
Yeah, yes, sir.
Yeah. So that's why, ma'am. So probably I have a call. That's the reason my colleague is calling up.
I understood you. Sir was like, sir is having a call now.
Yeah.
So
So, anyhow, what I want is from your all, and madam, probably you can summarize and give the list of participants who attended this today,
yeah,
and
yeah, surely those
probably
who
you
are
can drop me
interested
an
in.
official mail, and we probably accordingly we can take it further in the next consecutive calls, and we can have one-on-one discussion. Then. Not a problem. Okay.
Yeah.
So
Ma'am,
I
if
am
you
waiting
could
to
share
couple,
the email
but
ID of the sir Chandrakumar in place of the contact number, I think email ID will be better. That
yeah,
was
I will share my
Yeah,
number
you
with
just
that.
put your email ID here also. Those who want, they will directly contact you. But I will give you, because in some centers I have the coordinator's mail ID
Yeah.
only. So if they
I
are
shared my
interested or
number,
not,
ma'am. I shared my
yeah,
mail
it is
ID,
great. Yeah. So
and
sir has shared the mail ID, so that's better now.
yeah.
You can have
Okay.
the mail ID noted, and those who are really interested, you can directly contact sir, and you can have some sessions or workshops in depth. This is also a very good software which you can use, and they, like we also had gone through the demo. It is really very useful software. And I first of all thank Chandru sir within short, like maybe 30 minutes before only we had informed. But this shows, like your presentation itself shows like your knowledge in this subject. So first of all, I would like to thank you, and might be in future also I'll be calling you for detailed lecture of topics because of the short of time, and because
Sure, ma'am.
this was almost 1 year before planned course. So that's
Okay.
why I didn't include it. We will have special courses with Altair also next time, and I think more participants will be really interested to know more things in Altair.
Sure, madam. Sure. Thank you so much, and it was pleasure talking to you all and interacting. And sorry if I went fast or anything.
No, no,
Probably my mouth
I could
is just
understand. You said
yeah.
like you had a call at 11,
Yeah, yeah. That's
12:30.
what I need to drop. Otherwise, because I thought at 11, but unfortunately, Lavish told it is 11:30. Then
Yeah.
I couldn't able to say no. I just because I'm already associated with NITTTR, I don't want to miss a chance. Then I just presented.
Okay.
So
Thanks.
this is what
Thanks
was.
for
Thank you,
joining
madam.
with us within this very short notice, sir. And
Thank
we
you,
will
madam.
be looking forward for more
Yeah, ma'am.
interaction with you and more things. Thanks a
Yeah,
lot.
ma'am. Sure, sure. Thank you so much, ma'am. Bye, bye, bye.
Okay. Okay, sir. Thank you. So participants, actually, like this was in a very short notice. Actually, our ABB expert, he wanted to shift the lecture to 9th, and I have tried. Again, I'll contact him, and in case in the afternoon session we can shift, we can do it. And anyway, this software also, like I feel it's a very good software, and let us explore the student version which is available. And they have a university where they have put all these materials. So in order to learn in depth each and everything, even that will be a start for us to do a lot of research. So that was also like a good start for those who are starting with electric vehicles. And now, like I am just starting the break now, and at 2:30 we have a session with V Instruments who would like to show the demo of the electric vehicle what they have. So let us see that next, where it is a hardware as such an electric vehicle. So I was also very much interested to see the parts and how it is connected and all those things. So we expect that they will be doing a good session. So we will start meet sharply at 2:30. So now you can take a short break.
पक्की थी